I think we're ready to get started. My name is Lyndsey Padget. I am the founder and sole software engineer at Longplay Software. Kind of went out on my own and started doing consulting last fall, but I've been speaking for many, many years. I used to be terrible at public speaking, and so I forced myself to get out of my comfort zone, and now I do it quite a bit, and I really enjoy it. A couple of the different areas that I specialize in: microservices, REST. I do a lot of LAMP stack, Node.js backend, and now I'm doing a lot of Angular front ends. But today we're going to be talking about Git, which is one of my other passions. Git is the source control management of my soul, and I want to share it with all of you because I love it so much. That link there at the bottom is a link to the slides. Throughout this presentation, there are many links here, including my name and other things where you can hover over, click on them, and it will take you places. So I'll have that at the end as well. And you can always refer back to these slides, although I do reserve the right to change them whenever I want. OK, so I want to get a pulse of where everyone is on the Git journey. There's no right or wrong answer. We're going to cover both introductory concepts and some more advanced techniques. And I'm going to try to give you a breadth of the things that you really need, because Git can be really overwhelming and you may not know what you need. But by a show of hands, who here is using Git as source control for their job? OK. And how about TFS? OK. Some people raise their hands for both of those things, so that's interesting. Maybe it depends on the project. OK. And also TFS has like a gateway thing. It's weird where you're like interacting with TFS, but you're actually using Git behind the scenes. So that might be an option too. How about Subversion? Yeah, couple. All right. Hopefully no CVS or like FTP server, but I wouldn't judge you. It's a thing still. So I'm not going to go into a huge comparison of Git versus other source control management systems. I'm going to focus mostly on Git concepts. I just don't have time to go in comparing all of the different things, but you will find some similarities based on what you're used to, and if you have specific questions, you can ask those at the end if time allows. So I wanted to gauge where everyone is at, because I feel like this has happened to many of us when using Git. Still good for me to merge dev into BE now that the tests are passing? Yeah, anytime is fine. KK, yeah, I try to make sure the commit I use is the one that actually passed all the tests. That's about the extent of it. Yeah, I just did that. Haha. Oh God, PHP conflicts. A ton of conflicts. Should this be happening? I shouldn't have done this before coffee. So conflicts are scary. We're going to talk about some of those things. I've actually seen teams where there is a person who is responsible for resolving conflicts, both with people and with code. I don't recommend that. I understand that sometimes people they've been burned by it, right? And they want to kind of control that. But I want to help you feel more comfortable with conflicts in particular, or other situations like Git pickles, as I call them, that you've gotten yourself into. I'm also going to move my mouse, because that's annoying. There we go. OK, so a couple of things that I recommend. These are my opinion, but I've also based them in my experience managing teams before, as far as what is helpful for using Git. There are UI tools out there like Git Kraken and Tower, or maybe Tower makes Git Kraken, Source Tree, things like that. I strongly recommend not using a tool like that because it's too magical. It does things, you press a button, it all just works out, and you don't really, it takes away some of the learning opportunities that you can have when you're on the command line. So that's what I would encourage. I use a really beefed out terminal called Oh My Z Shell. If you're on Windows, you might use Commander or something like that. There are a lot of options to beef up your terminal and make it more ergonomic. You can set aliases and things like that, which come in really handy when you're using Git on the command line. Again, not required, but I feel like it's worth the time to invest. If you're not already using the command line, you're missing out on a lot of power and flexibility that you can have in your job. If you are not super comfortable with command line in general, I would recommend this series. It's Learn Code the Hard Way series. He specifically has a book on, understanding the ins and outs of like a Linux terminal type environment. We're not necessarily talking about shell scripting. Honestly, I don't remember if he gets into that here. There are other like command line tutorials that you can find online, so you don't have to do this one, but something like that, if you don't feel comfortable in general on the command line, I would encourage. And finally, there's this book, which is a free resource. You can download it like in PDF and Kindle version or whatever from the Git website, gitscm.com/book. And they always keep that up to date. So that's pretty nice. I think if you want a physical one, you can pay $50 and have that sit on your desk. And then since we talked about some of those other source control management systems, I want to explain like just some nuance in terminology. So Git is a source control management system, right? There are specific cloud providers that offer Git, such as GitHub, obviously, Bitbucket Server, which used to be called Stash. I don't know if you're more familiar with that term. GitLabs, and then the picture of the monkey is like representing how you yourself could set up your own Git server, which actually really isn't that hard. If you've ever set up like a local Jenkins server or a local Travis server, like it's kind of like a build system. It's very comparable to setting up something like that. And then all of this is kind of put into perspective with source control in general. So Git houses those things, and then you've got Mercurial and TFS and Subversion over there. Okay. One of my pet peeves, just in general, is like when people say GitHub and they mean Git or vice versa. Like GitHub hasn't cornered, they've cornered the social coding space, yeah? But you don't have to use GitHub. All right, so some basic terms that we'll get into. We've got NinjaCat here. This is from the Octo deck of GitHub. They have a whole suite of different kinds of cats. It's super fun. NinjaCat's got an empty folder on his or her computer. Git init will turn that folder into a Git repository. So just so you know, I'm not going to go into the terminal and show you all of these things. I've seen talks like that, and I think they're a little boring after a half an hour of watching that go by. So every command that I list at the top of the screen here is something you would type git and then that thing. So git init in your terminal is going to make whatever folder you are in a Git repository. And it does that by creating a, see if I can, yeah. It does that by creating this folder, which is hidden on many systems called .git. And inside of there, you will find all of the goodies for keeping history. I strongly recommend that if you're new to Git, you don't go in there and start yanking stuff out because you may not know what you're doing. And you can probably go find things on the internet around like the inner workings of Git if you are interested in what's inside that folder. Cloning is the process of taking a repository that lives in the cloud. So in this case, it's bitbucket.org/NinjaCat. And NinjaCat is going to say git clone and then the URL of that thing. And then, of course, he or she will have to authenticate. And doing so will simply make a copy from the cloud repo onto his or her local device. In doing so, there's this dashed line here. That is a remote, and we'll talk about that later. The first time you pull from, or the first time you clone a repository, it calls this remote origin. So that's like the nickname that it automatically assigns to that relationship. Forking is different. Forking and cloning get kind of easily confused sometimes. So this is Adventure Cat. Adventure Cat comes along and says, oh, Ninja Cat's code is really cool. I want to have it. I want to play with it. I want to do something to it. Maybe I just want to have my own copy. That's what forking is making a copy, but it's copying it in the cloud. So cloning is bringing it down to a local device. Forking, everything stays up in the cloud. Okay? And the difference there is whose account. Like if you're in Bitbucket or GitHub, it's just a matter of like whose account does it live under, but it's still just a copy. And again, that dashed line is a relationship between the two. So if Adventure Cat, different person now, if Adventure Cat comes along and clones his or her repository from this account, then this is going to be the origin, right? And this relationship is called upstream. These are just naming conventions. You can actually rename these remotes to be whatever you want. But if in this particular situation, Adventure Cat now has two remotes and can push code, theoretically, to either one. So we'll talk about pushing, but you'd have to specify upstream or origin depending on where you want that code to go. And same goes for pulling, right? Whether you're pulling code down or you're pushing code up, you have to now specify because it can't assume there's more than one. Actually, I think origin will be used if you don't specify because it's like the default. So I always specify. For me, typing these commands out on the command line, it's like putting my seatbelt on when I get in a car. I just habitually use the same format. So git, pull, origin, master. And we'll get into those, what each of those means. But by specifying origin every single time, I know exactly what I'm doing. Nothing is inferred. So in a realistic environment, Ninja Cat probably doesn't let just anyone push code to that repository, right? So I grayed out this line here because even though Adventure Cat can get code from the upstream repository, he can't push it back up, right? In order to do that, he has to push it to his own repository and then make a pull request. A pull request is really nothing more than something that you do typically through the UI of like GitHub or Bitbucket, and you would say, here's a branch. When you make a pull request, it is typically one branch to another, and if you change anything in that branch, it goes along with the pull request. You don't have to do anything special. It's just saying, you know, here, this number 23 or whatever ID it is represents this unit of code that I would like to give to you to put back in the upstream repository. Does that all make sense so far? Okay. We'll talk about branching, because that's pretty important. When you have an empty repository, it's almost like it doesn't exist. I mean, you've got to get a .git folder locally, but there's really nothing in it yet. It doesn't really exist until you have at least one branch with one commit. And this is part of the reason why GitHub, for example, will prompt you and say, do you want to make a README for this repository? Because it kind of helps like get things rolling. You don't have to. But that first commit actually is the action that, that makes the master branch. And again, these are just common naming conventions. Master is the default name that is given to the branch. If you've used SVN, it might be something like trunk, right? So, so we're starting off with one commit here. We make more commits. Each commit, which is a dot in this diagram, can be many files of code. You can source control pretty much anything, now might be a good time to mention that large binary files are the only thing that you might not want to keep in a Git repository. So for example, this entire presentation is running on Reveal.js and I have many images. I don't know, maybe 20 of them. If I had 2,000 of them, I probably wouldn't want to keep them in a Git repository anymore. Or if they were really, really large, like a website for a photography studio or something like that, right? Database files can run into the same kind of thing, but usually that's a whole different ball of wax, and usually there are systems that can help you like make backups and host those in the cloud. So in this case, there have been 3 commits. Each commit can have 1 or more file changes. At some point, you say git checkout -b, and then you specify the name of the branch that you want to create. So this action makes a new branch. In this case, it's called feature123. Now, I can't type that into my terminal because it's got a space, so I can either put quotes around it, or underscores or dashes are pretty common. You're on a specific commit, and when you say git checkout -b and the name of the new branch, nothing actually happens yet. This diagram accurately reflects what has happened, which is that there's just a new label applied to the same commit because you haven't done anything to that new branch. The minute that you make a commit on that branch, it diverges, right? And then at some point, let's say, for example, commits on the master branch have continued because someone is working on it, but you're over here working on feature 123. You make 2 commits, and then at some point you have to merge them together. The merge can happen as part of a pull request if you do pull requests, which I recommend. But if it's a really small informal project, maybe you don't. You should still branch, in my opinion, because branching is really valuable. Every time you make a branch and you push it to the cloud, you're saving your work. You can commit, which is all just local. And so think of it as a regular backup for your code. If nothing else, it makes it easy to get back to. This is an example where there's a conflict. The conflicting line of code, let's say, is changed once in the master branch here and once in the feature branch here. Now, GitHub and Bitbucket, for example, are pretty smart about resolving conflicts on their own. So some of the more common languages, C#, Java, Scala, JavaScript, HTML, it's pretty good at all of that. HTML is maybe the hardest. One reason to make small, or if you're going to make a front end that has HTML, you might think about chunking it up or having a system where you can make little templates and things like that. So, because it minimizes the risk of conflicts. But in this particular case, let's say it was the exact same line or the exact same area. 2 people did 2 different things to the same line. You would get a conflict here. And it's going to prompt you. It's not going to let you just move forward with that. You're going to have to resolve it. One more quick thing about conflicts is that if you guys have ever gone through a conflict resolution, you've got like arrows, right? So there's like forward arrows, dashes, and back arrows. I have made this mistake more times than I'd care to admit, but I will go through a file and I see 1 or 2 of those, and I'm like, oh, okay, yep, I got it. One of the chunks is mine, one of the chunks is somebody else from this diagram, right? But I miss some. Like way down at the bottom of the file, there's another one. So as a general rule, whenever I have conflicts, I like to search the entire file for those arrows, the caret, 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 so that just in case that doesn't get checked in, because it can really screw things up. Okay. So just a couple of things around release management with Git. I feel like this is an area where the power of Git could be harnessed much more, and people aren't necessarily taking advantage of it, specifically with build systems with CI. So tagging is extremely helpful. If you give versions of your software to people to use, which I hope that you do, tags are very useful so that you know what version that is. It doesn't have to, I mean, you can use like whatever you want. So here I've got 1.0 and 1.1. That's just a naming convention, right? If you want to label it Project Pegasus, you can do that too, okay? Tagging, there are like 2 different kinds of tags, and you can go read up on the differences between those. I'm not going to get into them here, but it's really, really helpful, especially for larger projects. You can refer back to those tags at any point, which makes it helpful for, say, finding bugs, right? Speaking of bugs, this is a common concept, right? A hotfix. A hotfix is a branch, so that's kind of why it looks like the branch I showed you before, feature 123, except in this case we're going to call it hotfix 237. You know, whatever naming convention the team uses is golden. Normally that's set by the architect or somebody, but even if you're working by yourself, you know, naming it what it is always a good idea in computer science, right? Just like variables. So this is a quick branch. Hotfix, as we all know, should be a really quick turnaround, right? Like, oh, I know exactly what that problem is. I'm going to make a quick branch, call it that, fix it in 5 minutes or an hour, and then merge it back in. The chance of conflict resolution is less because you're turning it around more quickly. Hotfix branches should not last forever. If they turn into a forever branch, you can rename the branch. And every time I have to rename a branch, I literally Google that because I don't have that memorized, but you can do it. Okay, so then there's this concept called Git flow. Who, by a show of hands, who's using Git flow here? Okay. Yeah, I like that. Like, because I think, yeah, it's this concept of how Git should be used, and then it may or may not apply in all cases, and there's always a little bit of variance between teams. But I wanted to show it here, so now that you have the understanding of general branches and how branches work, this is more of the Git flow model. Hub flow is like a little sister of Git flow, and there's slight differences there. So, but with Git flow, you've got a branch off of master called develop by convention. Develop is supposed to represent the code that your customers or users will have next. So master is what they have now. And so in this example, you gave them version 1.0, and then you gave them version 1.1. But at 1.0, you branched because at some point you're going to make 2.0. And like 2.0 is going to be totally different, right? So develop represents that work. And that can happen with several people or one person off to the side. Concurrent development is what Git is all about. So if you're, I know sometimes it seems like overhead if it's just you, but that's really the goal here is, you know, some people can continue to work on the master branch if that's what makes sense, and other people can go to develop. Off of the develop branch, then we have a feature branch because let's say it's a team of 10 people, right? The develop branch represents the work as a whole, but each person or each pair of programmers will be working on feature 1 or feature 2 or whatever. So that's kind of how that looks. Squashing is the idea of taking many commits and rolling them into one. What you sometimes see is it's just easier to deal with one commit and move that one commit around. Sometimes that's the reason for squashing. A like I've worked with architects that like squashing because it creates more of like a clean history. It makes it easier to navigate back and forth if there's a problem with the code. It's a little bit easier to roll back. And then the commit message I put here is, I'm so smart, I did this in one commit. I have literally done something like this because maybe I'm working on a project and I don't want, you know, if it's a hard to reproduce bug and I've been sitting there all night trying to get this thing to happen, right? And I've got a bunch of commits like, please work. Why don't you work? How about now? Okay, no, really now. Like, I don't want the customer or the client that I'm working with to see all of those commits because it's embarrassing. So I roll them all into one and have something like that. SemFlow is a concept that, that I came up with. So this is the shameless self-promotion plug. It's based on GitFlow. I was working at a company that was using GitFlow, but was also trying to do semantic versioning with REST services. And it really didn't suit their needs, mostly because the concept of develop and master from GitFlow implied that there are only two ever, right? There's the thing that users have, and there's the thing that users will have. But in many, many situations, you have to maintain more than two versions over time, right? And so this is an example just using semantic versioning, but you can take the concept and do whatever you want with it. The powerful idea out of it, I think, is that master doesn't exist. And when people who have been using Git for a long time hear that, they're like, what do you mean it doesn't exist? And it's like, well, it does. It's just called V1, right? You just change the name of master. So it's a little foreign feeling, but I believe in many cases it makes more sense. When you're talking about, you know, then going on to a V2 version of your API or whatever it is, you can develop features off of that and also have a version 3. You can carry commits from one branch to the other, and we'll talk about how to do that. So it's just, it was one of those things that I felt like we could break out of the mold a little bit, and you know, Git is so flexible you can do whatever you need to do with it. All right, so that's kind of all in isolation, right? Talking about branching is more like what's going on with the development in general, but now we're going to get back to like the real world situations of a team. So remember Ninja Cat and Adventure Cat. Actually, no, this is Ninja Cat's team, right? So Ninja Cat is, let's say, like the owner of the repository. He's over here working on this hot fix, but then there are other team members that are working on other things. So this is a very simple graph of what that might look like, using more or less a Git flow model. You've got Mega Cat and Spidey Cat and Stormtrooper Cat, all working on different features. Specifically, I want to point out Stormtrooper Cat because they have branched off of this branch. So a lot of times, you know, the typical use of Git is that there's some kind of main line. You branch, you go back in. You branch, you come back in. But this is an extremely powerful concept that not a lot of people are using, and it could be great. What I tend to see on teams is Stormtrooper Cat's like, well, I can't start my work because my work depends on Mega Cat, and I guess I'll just go play video games until he's done. It's like, well, no, you guys work together, and you have a branch already. You're just going to branch off of that one because, yes, it's true that one person's work does depend on the other, but that's what Git is for, okay? So all of that hotness is going on in the cloud on Ninja Cat's account, right? So all of those people, whether they're committing directly or they're making pull requests, we don't know, we don't care. It's like a team of people, and there's a lot of activity happening up in this repository, right? Well, poor Adventure Cat is over here. He's got no idea that any of that is happening. Part of the reason he's got no idea is because this is his origin, right? And because it's his origin, it's kind of like his default repository, he's mostly just going back and forth between here, day in and day out. But depending on the level of activity that is happening, or maybe the nature of the activity, it would also be wise for him to get to a good stopping point, make sure everything is backed up here, just like it probably ought to be every day, if not multiple times a day, but say, okay, I'm ready finally to pull in whatever work has been happening up here. That process is called fetch. Git fetch is simply the act of making this local repository aware of what has happened in the cloud. That's it. Nothing really changes, but if you think about this as a distributed system, which it is, these two things don't really know anything about each other unless it's time to sync up, and that's what fetch is. Just because this repository now knows about all of this activity doesn't mean that any of the code necessarily changes here. That's a separate command, which we'll talk about next. Merging. So we've talked about merging as it relates to branches together, right? But merging also refers to the process of merging in the fetched changes, right? It just happens that they're all on the same branch, most likely. So AdventureCat down here has gone to the master branch and said, git fetch upstream master. So that made it aware of the changes that had happened on the master branch. But then the next command would be git merge master, because it knows that there are new changes and it's going to update the reference. So you guys have heard of the concept of head. Head is like the leaf of a tree. It's the tip of the line. And so previously, if AdventureCat thought that this was the head of master, running this merge command will update the head to be here so that he's up to date with what has happened with everything on the team. And fun fact, pull is just fetch and merge together. It's a convenience. When you say git pull origin master, it fetches and then it merges. Okay? Any questions so far? It will fetch regardless, because it has to. And then it will merge, it will attempt to merge, but there may be conflicts. You're right. And technically what would happen in that case is it's like, hey human, I can't figure this out. Can you help me? And if you can't, like if you can't work through that, you can cancel the whole thing. The fetch has still occurred, but the merge did not, because you were like, ah, just kidding. Yeah. It depends on what branch you're on and or what branch you specify. So you can say git fetch and not specify anything else. It will make your entire, it will become aware of all activity that has happened. So let's say there were 10 new branches that existed up in the cloud. My local repository, after a fetch, knows about those 10 branches, but it doesn't move me to them or anything like that. But yeah, you can then specify, like if you're on master, I think you can say, yeah, git fetch origin, right, which is the remote, and then which branch specifically you want to fetch, because you might not want all of them. So yeah. Can one of the branches what? Okay, the question is, can you, as the person who's got the who's pushed to the branch up in the cloud, or maybe you're the owner of the repository, you want to prevent people from pulling that branch down. Okay, there are two different things there. Pull request, you know, yeah, they can absolutely deny a pull request, right? But then the code isn't even getting into the repository in the first place, so no problems there. That's a pretty good question, though, about the branch specifically. There are certainly protections that you can put on branches, such as no one can write to this branch except for these special people, or a pull request must be made and there must be 3 approvals on it before it can be merged into this branch. But that's only about code getting into the branch. And your question was about pulling code down. I don't know. That's a good one. So I'll tell you what I've done, because that has come up. I'm like, I've got a special branch and I don't want anyone to know about it. It's so awesome. I have 2 repositories in that case, just like AdventureCat does, an upstream, which is my team's repository, and then my own in some top secret place that no one needs to know about. And it's distributed, right? I have to obviously be careful, like don't break the law. You guys don't do that. But like, you know, depending on the ownership rights of the code itself, what machine you're putting it on, there are things like that to be aware of. But I've had a copy, and that's where I keep my branches if I don't want people to know that they exist. So you could have a local Git server that you use for that. There might be an easier solution, though. If so, I don't know what it is. That's a good question. Any other questions? Okay. I'm going to write that down, though. I'll follow up later. Yeah, this is just kind of the end of like where AdventureCat comes back into the picture, because AdventureCat now wants to become part of the team, and then he's going to branch off of develop here. Maybe he's not even officially part of the team yet, but there's this try it before you buy it thing, especially in open source. Like you need to follow our process, our team's process. You need to make this feature branch in a certain way from a certain place, follow all of our standards, you know, make sure you've got your unit test passing or whatever, and then after you do that for X months, then we'll talk about letting you onto the core team or something like that. So that's where AdventureCat comes into play, because after updating his repository with all of this activity, then he can choose where to branch from. Or maybe that's specified in the procedures of the team. Yeah. Okay, I'm going to talk about staging. How are we doing on time real quick? Yeah, we're good. Staging is a little bit complicated, and it will feel even more so if you're doing it through the command line, which is what I recommended. So if you've ever done it that way, you've got like red files and green files. Yeah. So that's what we're talking about here. So I am literally going to put a stage here because I think it helps reinforce it in your brain. You've got some files over here. These are just files on your system. This repository is also on your system, but you have to think about them as separate things, right? And then what's going to happen is things are going to move from the left side to the right side. So files are going to move from here through the stage into the repository. Okay? If I was better at CSS, I would have them actually moving, but I didn't do that. So first we've got this concept of ignored and untracked files. Those are 2 categories that files can be in. This file right here is special. It's called the .gitignore, and it tells the whole system what to ignore, right? This file right here is ignored because this file right here said to ignore it. So no matter what you do to it, the gitignore or the Git system will just never pay attention to it. For example, it would be very wise to put any like password sensitive key type information into a file that is then Git ignored. You would hate to accidentally check that in, right? These files are untracked because they're brand new files. They're not part of the repository yet. We will run the command git add, and it takes the files from that place and it moves them onto the stage. As far as it's concerned, it is now part of the repository. You haven't like made a commit with it yet, but that's what we're about to do. So when we say git commit, it adds those files to one of those dots, right? This is the dot that we saw in the branch diagram from earlier. And this is the message. You have to provide a message. If you are speeding through that part and you don't put a very helpful message, you will hate yourself later, because you might need to get back to the point where you did one thing or another thing because maybe you broke a unit test or you broke a button or something. Helpful, descriptive commit messages for the win. All right, so let's talk about modified files. These files have been here in the repository as they're tracked, and this one now becomes modified. So I just go into an existing file and I change something. When I say git add, it puts it in the stage, and again, I commit. I say, okay, I capitalize some names or something. Now I'm going to modify that file again, and I'm going to stage it again with git add. And then I say, oh, just kidding, I actually don't want to commit that, so I'll say git reset. That moves it back from the stage into the state it was before, which is modified. Okay? It's still like all the changes are there, it's just not ready to commit them anymore. That's what reset does. Checkout dash dash, so if you say git checkout dash dash and then the name of the file, erases all of the changes in the file. This is a helpful little tip, I think. As a general rule, anything with dashes in it is destructive. So if you find yourself typing a dash on the command line, you might be doing something dangerous. And so that's another reason why I like to do things on the command line. So git checkout dash dash is the command to say, hey, whatever it was I changed, just get rid of all that because it's terrible. Okay, so now we're back to kind of a clean working directory, as Git calls it. We modify another file here, and we add it. So we say git add my file, and we commit it. So this time we've taken it all the way to the repository, and we're like, I don't know, I'm just some stuff, it might or might not work. And then we realize, oh no, that was bad. I shouldn't have committed that. Now this is all local on Adventure Cat's computer, so it's not too late. If that commit was made by accident, you can back out. The way that you do that is git reset head tilde. The tilde is what scares people. It's rather cryptic. There is a system of, it's like how many steps back do you want to go? We talked about how the head is the tip of the tree, right? And if you say head tilde, it means go back 1. You can say head tilde 2, and it means go back 2. So there's a whole like naming, there's a nomenclature around that. There's also carets, which I rarely use, but you can. It's all just a way of like navigating which commit you want. Instead of saying head, like if that concept freaks you out because you're not totally sure what it's doing, you can also substitute anything like this, head tilde, with the exact commit ref. So you guys know the commit hashes, right? Each of those dots had a commit hash associated with it, and you can say, I want to reset to that point. Like I don't know how far back it was, but that one in particular, like I see it, that's the one I want to go back to. In this case, we know that we just want to go back 1 because we just committed something that we didn't mean to commit. So resetting it with head tilde will take it back to the point where it was staged. Everything is just like it was before, but it's not committed anymore. It's like backing up 1 step. If, on the other hand, you didn't mean to do any of that, So not only did you commit by mistake, but it's like, you know what, that was terrible code. I don't even want any of that anymore. You can say git reset head -- hard. Now remember what I said about the -- it's destructive. And so what that does is not only takes the commit out of the repository and backs it up, but it also undoes the changes to those files, like you never made them. And all of this is just happening on the repository of Adventure Cat's laptop. Nothing has gone anywhere. It's all local right now. Any questions on that so far? Okay. We'll get into some more tricks that are very handy or just more advanced concepts. So merging, we talked about merging already when two branches come together. It actually makes this commit here, which is a merge commit. This is the thing that maybe more meticulous architects don't like. They like to keep a linear history and a clean tree and things like that. So they might want you instead to rebase. Rebase and merging accomplish the same thing. They do it in different ways. Rebasing is the process of taking this feature branch, 1, 2, 3, and moving it to the latest, to the head of wherever it came from. So in this case, master. The end goal is to get whatever has been happening on the main branch into your branch, right? Your branch being feature 1, 2, 3. You've been working by yourself for like 2 or 3 days. Honestly, I wouldn't ever go longer than that. So if you've been working on a team where people go for like weeks without updating, that seems bad. I'm just telling you. So, you know, maybe you've been in a zone for a little while and you want to pull the code in. You can use rebase to do that. And notice that it doesn't make an extra commit. There's no merge commit in this case. Yes? Yeah, so are you talking about the concept of not having a feature branch at all, just merging straight to master? You can. If you are working on a team, let's say, bigger than 3 people, I would not advise it. You're just going to have many, many more conflicts. Although, maybe it depends on the nature of what you're doing. Maybe everybody's doing little tiny changes, and it's all like continuous deployment, and everybody's feeling good. Like, it might be fine. I'm not saying that you shouldn't. I think choose the right strategy for the type of project that you have. When you have branches like this, not only is it just helpful for things such as like somebody comes in and interrupts you and they say, oh, stop what you're doing. I need you to go look at this thing instead, right? You can switch gears. And for me, when I have many branches at a time, it's literally like closing a book, putting it on the shelf, and pulling out a different book. I can change context that way. Yeah? They're each ahead of their respective branches.
But in the case of the merge,
oh, sorry. I was trying to get back to the merge.
in this particular case,
There.
You're doing an actual merge, in which case if there are conflicts,
Yes.
when you do a merge, and let's assume the master branch is perfect.
Yes, like this.
Like this.
Mm-hmm.
In this particular case, so what happens if you send it doesn't catch it and these two branches?
Yeah, the merge actually technically happens here. Remember earlier we were talking about fetching and merging and how the fetch has to happen so that it knows that there are changes. But then the merge happens, and if there are conflicts, it stops right here. So it doesn't follow through with the arrow and merge it in. Right. So that's a good question. With rebase, there's also this concept called interactive, which I was about to get to. So interactive is different from general rebase because it helps you work through potential conflicts one commit at a time. And so previously, where it just jumped from across all of them, that can be quite difficult if there are many commits and you're handling all of those potential conflicts all at once. But with interactive, it allows you to work through it one step at a time. And so it still will not complete the rebase process until all conflicts have been resolved. So if you get halfway through this rebase, let's say you're doing an interactive rebase, and you get to step 2, on the second node, and you're like, this is terrible, just forget it, I'm going to go back. You can cancel the whole thing, and it will leave everything as it was before. Oop. It'll go back to this point. Yeah. So you might have things in your working directory that are now dirty because you tried to fix the conflicts. Yeah. And then you can reset them if you don't want to do that anymore. Or you can then go get your manager and be like, help me work through this. So you can kind of pause. One thing I want to mention too about rebasing is because this is quite common where you've got several commits here and several commits here. I am often working on a branch like this, right? And I don't need to see all of my history. I know what I did, or I know that it's good at this point, right? I'm not going to attempt a rebase until I'm comfortable with my own code. Now, some teams may not be okay with this, but in general, I found that most people don't care. I actually squash the commits in this branch first. So I make sure everything's good, I squash it, I push it up, so that this is actually just one commit. And that way it's not trying to work through the changes of each branch together, because that gets really tedious and scary. What it does though, when you squash, is it sort of rewrites history. So if you had some commits at midnight, it's not going to show midnight anymore. The squash commit is at 8 a.m. and so that's what it's going to show. That may or may not matter to you and your team, but it's a consequence of squashing. So
you'll lose all those previous commit messages then too.
Correct. Yes. But again, I found that while people think that they care, they really don't, because I do it all the time and no one asks. So again, like if
you're keeping track of what you've changed in your commit messages.
Yes.
You've lost that history to know what is in that type of set.
That's true. So yeah, he's saying that earlier I was talking about having good commit messages so that you can go back to that point. That's why I squash at very selective times. So I am very confident in what I have, and I'm not worried about having to roll back at that point. I'm far enough along. Now, let's say that I was. Maybe I'm not so sure, and I might need that code. That's a really easy a really easy solution to that problem is make a new branch. So I would call it feature 123 _2, or I don't know, that's kind of a crappy name, but you guys get the idea. So basically just make a new branch, leave this one alone. This new branch is going to come off of here, and then I can rebase or do whatever I want to it. And if it fails, I've still got my backup branch. So that can be really helpful too. You can make many, many branches as long as you kind of clean them up later and don't leave them around. It's not a problem. Cherry picking. I'm sorry I accidentally fast forwarded to this. So cherry picking is the process of taking a commit that is likely in the wrong place, meaning the wrong branch, and moving it to a different branch. So this can happen often because maybe we're switching context a lot and we're moving around in different branches. And I realize that the commit that is on feature 123 here actually should have been on feature 456. So cherry picking allows me to take that commit and move it here. But here's a fun fact about cherry picking. After that process is done, that commit is still there, because Git's not going to do anything destructive without you telling it to, right? So how do we get rid of this commit? Because it wasn't supposed to be there. So that's a trick. There are really two ways to solve this problem, and it depends on what you're doing, like the nature of what you've done. So first we'll talk about reset and push -F, which is for force push. This, as you can imagine, is more destructive in nature. It's also considered rewriting history. And if you are on the main line where people are caring a lot, you should not do this. Maybe you should never do it ever. Like, it depends on what you're comfortable with. But in a repository where I know that I'm the only person working on this branch, again, I do it all the time and no one notices because I know that I'm the only one in there, right? It is quite heavy-handed. It may not be necessary to fix the problem in this way. Honestly, the only time that you really would need to use a reset and a force push is when you have accidentally committed files that have sensitive information in them. So a password, right? Or some kind of secret key. If that happened to me, and actually it has several times, I would do this process, git reset, and then force push that, and then I would also go change my password, just in case. So that's one way of resolving the problem. Reverting is another way of solving the problem. So again, let's pretend that that commit is the one we want to get rid of. Reverting actually makes a new commit that is the opposite of what you just did. It's smart enough to figure that out, which I think is pretty cool. So let's say, for example, you accidentally turned a button from green to red, and you changed a style sheet or something. It's just going to set it back to green. And that commit is the green. So it's still in history. And changing a button color isn't a big deal. So this is probably the right solution for that kind of problem. But if it's a password or something, that would not be good. Yes?
Okay, I have a question about reverting. So
yeah.
Let's say that you merge something in here, and then a couple other people merge, and you're like, uh-oh, I need to rip this one out.
Yeah. You can't reset at that point because many people have been on that branch and they depend on that work, right? So reset was the earlier one where we do a force push. But in that case, you can absolutely revert that change. Yes, what you'll want to do is say git revert and then the commit that you want to revert, the one that you made a while back that was bad. And you refer to it as the ref, like the commit hash. Git's pretty smart. It can sometimes figure that out, and it will make a commit at the head, just like it ought to, that undoes your changes. Now, by that point, if a lot of things have changed, there may be conflicts in that process that you have to work through. Because yes, you did something bad, but then maybe somebody else worked around that, and you're going to have to resolve that. And that's when it's helpful to have humans talking to each other too. Be like, hey, I'm doing the right thing, right? So yeah.
So the way you said that is not to revert the merge, but to revert the change, the other change.
Correct, yeah. So in the example where you accidentally turned a button from green to red, it's that commit, the commit where that happened, that you are specifying to this command. You say git revert the bad thing. And the bad thing is the bad commit hash. Yep. Question? Yeah. Yes. You can do whatever you want if it's local. Yeah. Including that reset, force pushing, like it's all yours. It doesn't matter. But yes, the rewriting history is particularly dangerous when you're pushing and other people then have access to it. But yes, all of this can be done locally, and then maybe you test it, make sure it's right, and then you push the whole thing because you want to go fix that problem. Bisect, it's kind of obscure, but it's a really cool trick that is already built into Git. So let's say there's this more complicated problem, right? The button doesn't work anymore, and it's been broken for a really long time, but we're not sure how long it's been broken. We know that at some point it did work. Bisect is the tool for that job. So in Bisect, you can label a commit hash as bad, and then you can label a commit hash as good. And there could be hundreds of commits in between here, right? Nobody wants to spend their time going through every commit figuring out if it broke. Bisect is a binary tree for your Git tree. So it will go through this lineage and figure out, based on either manual testing or a unit test, whether it has broken or not. What it will do is it will move your head, like your detached head, around based on a binary search algorithm, so that you can triangulate where the problem occurred. And it's just going to move you around and you can test it manually. But if you've got a unit test that demonstrates that the thing is broken, even better, because you can give that to Git Bisect and it'll just run and it'll tell you exactly where it got broke. So that's another reason why unit tests are awesome. Submodules is kind of a weird concept. If you're new to Git, I don't recommend it, but some teams use them, so I thought I'd talk about it. The concept of submodules is that it's a repo inside of a repo. So this is most often used when there's this huge enterprise project, and then there are like modules that each team works on. So each of those modules is a repository in and of itself. And the way that this works is that there is a link, which I haven't pictured here, but it's like a link between the parent repository head of whatever branch and the child repository head. Like that's the relationship there. Part of the reason I don't like submodules, besides the fact that it's a little mind-bendy to keep track of what's going on, is also that it doesn't prevent you from module inception. Like you could just have child inside of child inside of child. Git inception all day long seems like a bad idea. These are a couple miscellaneous things, but very, very helpful. Git status. I type Git status so much, hundreds of times a day. So many times that I have set up an alias for S. I just type S, enter, and it runs Git status. That tells me what's staged, what's modified, what's untracked. It kind of gives me a sense of where I am. Git log is a history. You can customize the Git log. I will admit that by default, it's not a very readable log. It kind of makes your eyes bleed. So you can go find different commands and configuration for making your log pretty. So you would want to go to Google and just say like get pretty log. And there are ways that you can make all different colors and stuff like that. One thing I want to point out about Git log is that on your local system, I don't remember, but I think that the latest commit is at the top. But if you're on GitHub, for example, depending on the view that you're looking at, the latest commit could be at the bottom. So just pay close attention to whether it's newest to oldest or oldest to newest. Because if you're looking at some UI, either like source tree, if you're kind of weaning yourself off of that, or you're looking at the UI on the cloud platform, it could be a different sort order than what you're seeing locally. Git stash is a thing you can do when you've got some files. You are not done with them, so you don't want to make a commit, but you really don't want to lose them either. Most likely this is because somebody has come to you and said, you need to stop what you're doing and look at this really bad problem. And you're like, okay, I don't know what to do with these files now. So you say git stash, and it actually moves them into this secret folder in the .git folder. And stash is actually a stack. So it takes those files and it almost does like a pseudo commit and it pushes it onto the stack. It's weird. I would highly recommend that if you are going to do a git stash, like if you run into that situation, make a new branch. Branches are cheap. You could just make a new branch, commit it locally, and maybe it never goes anywhere. I've also heard a tip where you can commit it locally, and then when you get back from lunch or you're done putting out some fire, you just back that up with git reset. So there are different strategies you can use. If you use stash a lot, just be sure that you know what you're doing. Because pushing and popping things off of the stack, like I do it one time. I don't try to get fancy with my stack. Like it's asking too much of my brain. So I'll do it occasionally and I'll say, okay, put this in a stash, but it's almost like having something in your clipboard, right? Where you copy something and you're like, I don't want to lose this. I need to not copy anything else. So it's akin to that. Aliases are something that I would recommend. I've kind of referred to those. Here are just a few of the ones that I use. I would recommend waiting. If you're new to command line or Git on the command line, learn the whole thing because it's helpful. And then once you feel super comfortable, then you can make an alias that makes your life a little bit easier. This part is to show that I actually sync these up. So I have like a file for configuring my Z shell, right? And that's where I store my aliases. But this is held in some sort of cloud provider like Google Drive or Dropbox or something like that. And what that does is it allows me to move from computer to computer to computer, and they're all referencing the same file. So if I add an alias on one machine, it's not really on that machine. It's linked to that file in the cloud, and then I can use it anywhere, which is really nice. Diffing is another thing that is really painful, admittedly, in the terminal. So if you say git diff and then the file that you've changed, you want to really be sure of the differences there. That's no time to mess around. So if you feel comfortable doing it in the command line, more power to you. I will admit that this is the one place I go out of the command line. I use a tool called Beyond Compare. I think the license was like 30 or 40 bucks, and it's like a license for life, essentially. Cross-platform, best thing since sliced bread. There are other tools called WinDiff, Meld, things like that that you might look into for your specific platform. And that's pretty much it. Let's see if we have, I'm sure I'm running out of time. Yeah, I'm over. But if anyone has more questions, you can come up to me afterwards and we can talk through it. But I appreciate everyone sticking around this late, and now it's time to go have fun. So thank you.